the next group. We're going to graph each piecewise function below. Remember that the piecewise functions we graph one at a time, each piece individually. So number 19, the first piece here that we have is a line, okay? And its y-intercept is at +4, and it's got a slope of -2, so down 2 over 1. I can also go up 2, left 1, up 2, left 1, up 2, left 1, 2, left 1. Okay? So now I have this here, and I can draw this. But realize that, oh, let's see here. Let me try giving myself a line. Okay. So I only want to go, though, from -2. So -2, I come up here and I put my point, and then here's my line that I'm drawing. Okay. Now, one little thing here, though, is that it doesn't actually exist at -2. So what I need to do is I need to come along and I need to make this point, oops, this teeny tiny little point that's going to be at this spot. Let's see if I can do this right. We're going to make the line color red, but the inner color white, so that way it's an open point. Okay? Now, the next part of it, and then what I can do is I can come along and I can erase out this part. This next is an absolute value, or a V-shaped curve that went down 3. So I come down 3 and I've got my spot. It occurs anytime x is greater than -2. So if I go right 1, up 1, right 2, up 2, I can do the same thing on the left-hand side, but as soon as I go left 2, okay, I need to put a solid point here because I don't go any farther to the left. Now, I can do this guy like that. There's my piecewise function. It's a line and an absolute value. Number 20. This has got 4 different pieces. So we're going to do each piece individually. This first piece is a horizontal line because y is 3. Yay, I can do that. Anytime x is less than or equal to -4, y is 3. So I can do my horizontal line here. Now, between -4 and 1, I have 2x plus 1. So y-intercept at 1, slope is 2, and I go up to 1. So I've got a solid point here, and then at -4, I've got down to 2. At -4, I'm going to have an open point. So I've got an open point right here, and then I connect that line. That's the second piece. The third piece, okay, the third piece starts at 6, okay, it's a line with the y-intercept of 6 and a slope of -1. So I'm just going to kind of dot him in because I'm actually only going to start him from 1 with an open point, and he goes all the way up to 3 with a solid point. Oops. So I just have this piece here. Okay? It's a lot easier when you've got a straight edge and you can write on paper. This last part is a parabola. This parabola went to the right 6 and then up 3. There's my vertex. And it's flipped upside down. So I go right 1, down 1, right 2, down 4, and then right 3, down 9. So I should come down here to 6, and this is going to be an open point. And then over here, the nice thing is it's just going to be an arrow. So I draw my parabola, and I do my arrow, and that's it. You drew all 4 pieces. 4 pieces, 1 piece at a time. This tells you what, oops, this over here just tells you what little horizontal window you're looking at. Number 21, this is a piecewise function. When x is less than 0, y is equal to 3. Well, that's easy. We put an open dot here, and then it's just a horizontal line. That's yay. Now, at 0 up to 8, it's the square root, and then up 4. So this goes up 4. I'm going to have a point here, and then it's got a horizontal stretch of 2. So I go right 2, up 1. Okay. Now then I'm going to go right 8, which gets me all the way out here, because that's where it is. And 1/2 of 8 is 4. The square root of 4, or half of 8 is 4. Square root of 4 is 2. Plus 4 puts me at 6, which is also going out 8 up 2. And this is going to be an open point at that spot. And boom. There I have it. Okay? Questions there? All right, next page. This page says use the piecewise functions above, which you saw, to evaluate the following. Okay, f of negative 2. Now you can't see them, but you can see them because you're looking at your paper. So if I look at f of negative 2, that means that I'm going to use the absolute value of negative 2 minus 3 equals negative 1. I'll go back a page. Okay, f of negative 2. X, when x is greater than or equal to negative 2, I use this piece to evaluate. That's how I'm doing it. So, f of 7, well, I'm going to use absolute value of 7 minus 3 is 4. G of 5. Let's go back and check out G. G of 5, that's down here. I'm going to use this 4th piece. So I got to pick one of 4 different pieces. So G of 5, I get negative 5 minus 1, or sorry, 5 minus 6, quantity squared plus 3. That's negative 1 squared is 1 times negative 1 is negative 1 plus 3 leaves me with 2. G of negative 4, well, remember, that's just 3. Anything less than 0 was 3. G of 0 was 1. Remember, at this point, we do 2 times 0 plus 1 with the second piece. G of 2, we get negative 2 plus 6. That's equal to 4. And let me go back just so we can kind of look at this. So G of 2, 2 uses this piece. 2 is greater than 1, less than or equal to 3. That's what I'm doing. I pick my piece based on what x is, and then I evaluate it using the function rule to the left. Okay. H of 9, ooh, this is no solution. Why? Let's go back and look at H. H of 9. If x is equal to 9, 9 is not less than 0. 9 is not between 0 and 8. It doesn't exist. Okay? This is like saying that the body mass index of somebody that's negative pounds. You can't be negative pounds. Okay? It does not exist. H of negative 4 is just 3. And then H of 6, that's where we do the square root of 1/2 times 6 plus 4. This is the square root of 3 plus 4. And if there was no calculator, this would be your answer. If you can use a calculator, it's about 5.732. Okay? Now, this next part, you have to actually write the equation for the piecewise function. Well, first figure out your domain. Okay, let's figure out all of our pieces. We have here, we have here, and we have here. So we've got 4 pieces. Remember, at any particular x, you can only have equal to it once. So for this piece, we could say that x is less than -2, and at that point in time, it's just 5. I like my horizontals. Over here, between 1 and 3, 1 less than x less than or equal to 3, it's just 2. Isn't that nice? So those 2 are the easy ones. I would always do my horizontal ones first. Now, the parabola. The parabola is not bad. It's just raised up 1, and then we go right 1, up 1. So this is x squared plus 1. Now, -2 is less than or equal to, because I've got the equals here, x. I have 1 is just less than, so less than or equal to 1. Only the x value can only be equal in one piece. Finally, the last one is this line. Well, the line has a slope of -3. Great. So I've got -3x. But I got to figure out what the y-intercept is. Well, for something like this, you can do lots of different things. You could do it algebraically, or you could just go 1, 2, 3 here. Oops, give myself a 1, 2, 3 here. 1, 2, 3 here. So you're up to 8, right? You're going to go up 3 more, so you're going to be at 11. So now I've got -3x plus 11. All right? You can just count it backwards. The other way is to algebraically figure out the y-intercept given the slope. Okay, slope and a point. But when you've got a graph like this, sometimes it's just as easy to count. All right? Now, when does this occur? This occurs when 3 is less than x, which is less than or equal to 4. Boom. You've written the piecewise function. Not bad. But you just have to be able to write lines, parabolas, absolute values, things like that. On to the next page. The next page, graph the following inequalities in 2 variables on the coordinate plane provided. Remember that y is greater than above, y less than below. Equals is solid, not equals is dashed. So, first things first, graph the 2 shapes. This first one here, we're going to do it in red, and it's going to be solid. So this went left 1, down 3. There's my vertex. No stretch or compress. So right 1, up 1, right 2, up 2. What I do on the right, I'm going to do on the left. And here I graph. Whoop, hang on. What happens when you hit it with your hand in the wrong place? Okay. So there's the graph of the absolute value. Now, we've got the parabola. This one went left 1 and then up 3, and it's upside down, and it's also dashed. So right 1, down 1, right 2, down 4. Whatever I do on the right, I do on the left, and then I'm going to do this. Now, to shade, remember that I am shading below the red and above the green. So below the red and above the green. Below the red, above the green would have me shading in this area. Okay, up here is above red, that's a no-no. This is below, but above, you got to look at where you are overlapping. Okay, so there's the first one. Let's look at the next one. Get my pens back. All right. This first guy is an absolute value. It went right 3, up 5, and then it's upside down, but it's solid point. So this is so much easier if you've got a straight edge. Okay. And the main reason here why you want to make it go all the way out is because you've got to figure out where everything crosses. Okay. Here we have a parabola. It went to the left 2, down 1, and then it's got a vertical compress. So I went right 1, up a half, right 2, up 2. Whatever I do on the left, I'm going to do on the right. And this is dashed. So dashed. And again, this one is below the blue and above the purple. Below the blue and above the purple. That would give me below the blue and above the purple. All of this region. Okie doke? So far, so good? Yay. The next two. All right, let's see here. Nope. Okay, we've got an absolute value that just went down 3. So down 3, and then absolute value is pretty easy. Right 1, up 1, right 2, up 2. And it should be dashed. I'll dash this side. I'll come back and just make erasers on the other one. Bump, little guy. Boop, 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 boop. Okay. The next one is just a line. Notice this isn't a parabola. This is just a line. This should cause no one heartburn. Y-intercept of -1, slope of 3/7, up 3, to the right 7. Okay. Or you could go down 3 and to the left 7. And this is going to be solid. All right. Now I want above the red and below the blue. Right? I want crayon. Boom. Okay. Below the blue and above the red. So I'm in this area. Okay, I'm making corrections to things too. So, all right, number 30. We've got, again, we've got a parabola that's upside down. So we go right 2, up 5. And then it's upside down and stretch 2. So right 1, down 2, right 2, down 8. You can pay attention there. Sometimes I can't count and speak at the same time. This is dashed. So there we go. So that's dashed. And then we have an absolute value that went to the right 1, down 2. And it just goes like this. And it's solid. And then we get the crayons out, just because they're much easier to color things with. And we are going to be above the parabola and below, so above the parabola and below the absolute value. So we're going to be below the absolute value and above the parabola. That will put me in here. Okay? All right. Now, the next group, you actually have to write the answers. Okay? You actually have to write the solutions. So here, we're looking at, let me get my pens back. The first one, I would first just write, I've got a V shape. So I know I'm going to have y. It's shaded below, less than or equal to. I went right 1, up 2, so it's got a vertical stretch of 2. And then I went to the left 1, so x plus 1. And then it went down 1, 2, 3, 4. So there's that one. And then the other one is a parabola, so it's y, and I'm shaded below, so it's y is less than. It's upside down, so I'm going to have a negative. Right 1, down 1, I'm good. So I'm going to have x plus 2, quantity squared, plus 1. It went left 2, up 1. All done with that. Next one over here, we have y greater than negative absolute value of x plus 5. It's dashed. It's upside down. I got that going on. Now the next one is just a line. So I'm going to have y greater than or equal to, because it's solid, the slope down 1, right 3. So negative 1/3 x, and I'm crossing the y-axis at 2, which is my y-intercept. And I'm done. Number 23. Number 23, we first have y less than negative absolute value. Okay, it's less than because it's shaded below it. It's negative because my v is upside down. Then I went to the right 5, so x plus 5, and then it went up 5, so that's going to be plus 5 out here. And there's no stretch or compress because I go right 1, down 1. For this guy, notice it's a parabola. I went right 1, up 2, so I immediately know I've got a stretch. And I'm shading above, and it's solid. So y is greater than or equal to 2. This went to the right 3, x minus 3, quantity squared, and it's down 6, so minus 6. Not so bad, right? Getting the hang of it? I hope so. All right, next one. We have a line that's solid and shaded below. So y is less than or equal to. It goes through the origin. Hooray! And it's got a slope of 1. So y is just less than or equal to x. The next one is a parabola. Right 1, up 1, there's no stretch or compress. It's solid and shaded below, so less than or equal to. And then I'm going to have x. It went to the right 3, squared, and it went down 1. All done. Okay? That's it for writing inequalities. Now, applications. Suppose that h of t is the height in feet of a rocket after t seconds. In practical terms, what does each of the following represent? In practical terms, an example, h of t minus 1 means the rocket is fired 1 minute later. Okay, so 1 minute later. We're going to go here, and we're going to go way down to like 12. All right. So h of t plus 3, that means that the graph shifted to the left 3. So this means the rocket was fired 3 minutes earlier. That is the practical meaning. Remember that we have our x and our y axis, okay? And if I just come here and I say minutes since fired, and then I have height of rocket, okay, that's on the y-axis. The down here is minutes since fired. So up here, I'm going to say that the rocket was fired 2 minutes later at a spot 4 feet higher than original location. Okay? Oops, I'm sorry, these should be minutes, or my bad, this should be seconds. Seconds, and seconds, seconds, because it says seconds up here. So I can't change the other one. I should say second. Okay? Down here, we have 2h of t. Okay, this means that after t seconds, the rocket is twice as high. Okay, that's 2h of t. I want to be twice as high as the rocket is t seconds after it's been fired. Right? Again, this is just understanding what does an equation mean. It's great if you can punch buttons and get numbers, but you've got to understand their meaning. Now, use the following information for problems 38 through 40. Your cell phone plan costs $55 a month. This price includes unlimited talk, 500 text messages, and no data. Your plan charges 10 cents per text message over 500 included in the base price. Write a piecewise function to represent your cell phone plan. Well, okay, your cell phone plan. We'll call it our f of x. And you have two different things. You could not go over 500 text messages, right? In which case, you will pay a flat rate of 55. And x, by the way, is the number of text messages. So 0 less than or equal to x less than, this price includes unlimited talk, 500, less than or equal to 500. So as long as you have no text messages up to 500 text messages, your plan is $55 a month. Now, if you go over 500, you have to pay $55 plus 10 cents times every text message. Oh, but wait, it's not every text message, right? It's every text message over 500. So this is going to be x minus 500. Why? Because the first 500, these were free, or they were included in the $55. And this is going to be 500 less than x. So if you talk for 578 minutes and send 375 text messages, how much will you pay? Well, I don't care about this. This is what I care about. 375 falls between 0 and 500, so I'm only going to pay $55. On the other hand, if I talk for 320 minutes, again, doesn't matter, that's unlimited, but I sent 872 text messages, how much will I pay? Well, 872 minus my 500 included ones leaves me with 372 text messages that I have to pay for. So I'm going to have to pay $55 plus 10 cents times 372. 10 cents. Is it 10 cents or 5 cents? Your plan charges 10 cents? Yep. So 10 cents. So this is going to be 55 plus $37.20. When you do that, you're going to have your 20 cents out here. Okay. You're going to have $92.20. That's what you're going to pay. Okay? All right. That's the end of the review. Great job.